பாதையில் செல்லுவோம். கல்வியே கண்கள் என்றுமே புது தலைமுறை நம் பெயர் சொல்லுமே.
Dr.M.G.R. Educational and Research Institute, University, Maduravoyal, Chennai.
Let's start.
The sky is not limit for us. We are the students of Satellite team is geared ourselves to go beyond sky. That is sky, satellites and rockets. We are very delightful to inform about Dr.M.G.R. ACS Space Technology Center. We are also planned to have a national seminar on Jan 30 to 31st. Glad to be part of this. Let me request Dr. Subhasri ma'am, Joint Register, ENT first year, to share her views. Welcome ma'am.
Thank you. So, I welcome all the dignitaries for this orientation session. Special welcome to Dr. Cyril Raj sir, Additional Registrar of our university. Welcome sir, and I welcome all the staff and students, those who are connected with the Satellite project. So this session today is regarding an orientation. For what the orientation is done is, our Dr.M.G.R. ACS Space Technology Center is organizing a national seminar, Space 2.0, an era of small satellites, big application opportunities and challenges. And this is scheduled on 30 and 31st of January 2023. So in this regard, there were many queries that was raised by students. So we thought an orientation session as how to apply and what will be the benefit and what can be the or how the student can take up the journey as a satellite engineer, right? So taking this into account, we have organized this orientation session. So for this, we have a team of staff and students from the Dr.M.G.R. ACS Satellite Technology Center, and they will be educating the students, and they will be providing you all the details and all that is happening in the center. So once again, I welcome everybody, and I request the students to take up the session with full interest and register for the national seminar. Thank you for the opportunity.
Thank you, ma'am. Regarding this, let me request our Dr. Cyril Raj sir, Additional Registrar, Dr. M.G.R. Educational Research Institute, to brief about journey of Dr. M.G.R. ACS Space Technology Center. Welcome, sir.
Thank you, Madam Bala. First of all, I would like to thank the Joint Registrar ENS courses, Dr. Subhasri, for providing this wonderful opportunity to talk to the first year students. Dear students, in fact, we have talked to you in many occasions, but this is one of the very, very important occasion where we wanted to brief you about how this university is different from other universities. Dear students, I think you may be from different engineering fraternity, right? From electronics to electrical to mechanical to computer science, AI. So you may be from various programs, but the thing is, this the satellite and then space application initiative of our university is really going to provide you very, very extraordinary opportunity for all the students community. I think some of you, I mean, most of you would not have visited this facility, which is there in the main block of our university. We have a separate satellite and space application center as well as a laboratory there in the RA block, where our management have invested around a crore rupee for developing satellites and then satellite related applications in general, the space applications. Dear students, you may be wondering what is the role of a first year student in this particular domain. But the thing is, when we started last year, it was only with a handful of the first year students, actually this laboratory was created, but now if you come and then see the level of knowledge and then the authority the student have developed in this particular domain, really it is astonishing. Uh, because actually these are very rare opportunities students are getting in institutions. So we want you to utilize these opportunities also. So normally we used to identify around 30-40 students who can work on this particular domain, because if you see the future opportunities, this particular satellite and space applications is going to give opportunity for many inter-domain applications. So, and then that too in our country as well as in throughout the other countries clear. This particular domain is opened up for private players also. If you take our country, it was only that Indian Space Research Organization that they were the pioneer in sending, designing, manufacturing satellites and then sending it to various orbits for various purposes. So all these things were taken care only by ISRO. But right now it is opened up to all the private players also. Recently, one Hyderabad-based company, they have launched their own racket also. I think, dear students, you may be aware about the Elon Musk, the SpaceX program also. There are a lot of reusable rockets being used to shuttle cargo between the International Space Station and then back from space station to Earth. So all these things, and then right now, same Elon Musk is right now sending around 3,000 satellites across the low Earth orbit to provide the direct internet connectivity also. So right now, through our landline as well as through our cell only, normally we used to get our internet connectivity within a few years. So we are going to get the satellite-based internet, seamless connectivity across also. So all these things need, special, skilled, professionals like us. So this laboratory of our university is very, very unique. Only very few universities across our country are having such a facilities also. Then the offshoot of this particular laboratory, like we are concentrating on the drone technologies also, where again government of India have opened up the opportunity for startup in this particular drone in different applications, right from the defense to agriculture to goods delivery, and then medical, all these things clear, where the drones are going to take a very important role also. Um, so in a nutshell, actually, we wanted to show you what are the special opportunities that are awaiting you. As already I told you, this the satellite and then the space applications. If you see the traffic, so right now when the Chennai city is meant for traffic, at the same way, if you see the number of satellites and then the dead satellites, unused satellites over there in our orbit, which is rotating around our Mother Earth, it's numerous such a dead objects are rotating. So it has to be properly managed. It has to be, brought back, or otherwise it will be a potential threat to, flights and then other satellites also. So again, new student projects are coming up. How to identify a object, even that too of 1 centimeter size in the space also. So there are many challenges, and then how to capture those dead objects and then how to bring it back. So many such opportunities are awaiting, and then so dear students, so in order to make our students to understand these opportunities, our university is going to conduct a 2-day national level seminar on 30th and then the 31st of this particular month. No, we are expecting around 200 participants across the various institutions also. But at the same time, our management is insisting on rather than giving this opportunity to outside our campus, so why don't our students get this opportunity? So this is what actually the view of our top management also. So that's why actually we are here to tell you, what are the developments. A first year student of this particular laboratory, when they entered, they were nothing, but how they have developed their knowledge, all these things are going to be demonstrated by the students who are there doing various projects in this particular center. I hope if you attend such a program, so definitely it will be an eye opener for you to think differently. Clear. So now it is the future is only for the person who could able to think disruptively. Clear. Disruption. So that's what. Unless you have the cross domain interactions, and then thinking differently, then only the future is for you. Listen to this particular presentations of our students, so that you will come to know that what are the opportunities. At the same time, by participating in this particular 2 days nation level workshop, where leading scientists across the globe are going to come and then share their valuable experience in this particular domain. Here, this domain knowledge, nowhere you can get it. So definitely it will be an eye opener for all of you. So try to make use of this opportunity, or otherwise the outsider will get the benefit of these opportunities. So for this, let me give the stage to our beloved student community who have done a lot of work on this on this satellite and space applications. Thanks for listening to us.
Ultimately, the students receive a wide glimpse of knowledge regarding this. May I request Shrutika from Department of Biotechnology? She is going to present on the topic of cancer.
Thank you so much, Bala Vigneshwari. Good afternoon, good evening, everyone. I am Shrutika, third year from Department of Biotechnology. I'm delighted to be a member of Dr.M.G.R. ACS Satellite team. You might puzzle being a biotech student, my role of biotechnology in it. I had the same doubt before entering our center, but when I got into our team, the puzzle was solved. As soon as I joined our team, we got avenues of opportunities to witness a lot of workshops, internships, conferences at ISRO, TSC, and ITCA. All these were completely sponsored by our MGR University, like starting from the accommodation, traveling, and other expenses. So here is a glimpse of and multifarious activities of our satellite students, which was organized and sponsored by our university. This is how our journey started. The process. So here is our journey towards the success. So the first it all started with the MOU signed between MGR and ITCA, and this was the beginning when our Prime Minister, Honorable Prime Minister, announced that on the commemoration of 75th year of independence, India is going to launch 75 student satellite into space, which Indian students are developing in across several colleges and students. And we are proud to say that our university is a part of this 75 student satellite mission. From there onwards, our journey has started. So here is our proud family of 35 members of students and staffs of Dr.M.G.R. ACS Satellite Development Team on Prime Minister's 75 Student Satellite Mission. So the first visit was to Kelambakam, Chennai. From there, we learned that the drones manufacturing fabrication of 3U and 2U CubeSats. So here is the pictures of the visit. So the next was the visit to Alpha Technologies, Bangalore. So this was such a wonderful place, and not everyone are allowed inside this place. It has a lot of custom securities, as the major Indian Army parts of radars are manufactured and designed here, which we get designed from Israel. So it was a very wonderful experience to visit the Alpha Technologies, Bangalore. The next visit was to Visvesvaraya Industrial and Technological Museum, Bangalore. When we went here, we got an overall glimpse of what is space, what is happening in space, different parts of space. So these are some of the images. So next we visited to Nettu Technical Training Foundation, NTTF, in Bangalore. So here it was an institution in which we have seen interdepartment things which was happening, and we were amazed to know there are a lot of technologies, new machines, so much of information and knowledge we gain. The next in the process of developing the student skills towards the presentation and the knowledge, we proclaimed the concepts and development of one new satellite team we have presented it to our staffs. So here is a photo of all that. Our peer team has visited to the Kalpana Chawla Center in Chandigarh University at Punjab. So anchoring the satellite research aspects from Kalpana Chawla Center for Research in Space Science and Technology at Chandigarh University. So this is an insight in in-house space laboratory at Chandigarh University. Here is our teachers team presenting the design review of one new satellite framework. The team of students and staffs at ASI conference. So this is again another big opportunity for us to witness a national and international conference. So ASI Astronautical Society of India, they have together joined with the Space on NISL 75 student satellite and in space to conduct a conference, national conference. So here are the images with our satellite team with our Dr. Somanath, ISRO's chairman at ASI conference. This is the rocket which we can witness in front of our college. So this is the moment when we unveil the rocket model GSLV Mark 3 D2. So our chairman is unveiling the rocket. This is the M.G.R. space visit by Apple projector director Dr. R.M. Vasagam at our center, M.G.R. Space Technology Center. The next visit was to BSX International Space Expo at Bangalore. Here I think as sir mentioned earlier, the Skyroot Aerospace, which is at the top of private sector, which is going and launching rockets. So we were given opportunity to witness all of those Skyroot Aerospace data patents and so much such companies as Dhruva Space, etc. So here is a glimpse of all the photos which we took with all the Russian cabinets, etc. And all these people were from Roscosmos Space Industries. And at last, finally, we attended a workshop on space international awareness on space traffic management 2023. So here are some of the images. So be the nebula of imagination, create, unleash, innovate, and let the M.G.R. CubeSats fly. So another great opportunity through our center was to present ourselves in different competitions such as CANSAT, India's CANSAT competition, World Rocket competition, etc. So we like to know more about CANSAT. I'm going to present a PPT on it. So CANSAT, can you just imagine a satellite is fitted into one can? So that is what we call it as a CANSAT. So here, this is a competition in which we students are facing that all the components present in a satellite has to be fitted into one can shape. So you might wonder how it can be possible. So that is the competition. And here is the CANSAT India Student Competition by InSpace 2022. So the CANSAT, as what is a CANSAT, as I already said, it has to be under 1 kg and it has to be in a can shape. All the subsystems present in a satellite are fitted into the can. So this is all about the history of CANSAT. And what is inside a CANSAT? The main parts inside a CANSAT are OBC, EPS, communication systems, and payloads. So these are all the subsystems which is present inside a CANSAT. You have to fix all these subsystems, electrical subsystem, into a can to get the mission successful and completed. And our objective in this competition, our objective was to prepare a CANSAT weighing under 1 kg, and it has to be in dimensions of 0.125 meter. You can imagine how small it is, and 0.31 meter. The main objective was that we have to have a descent control system and a mechanical gyro support to descend the CANSAT at an altitude of 500 meter. So this is a system operation concept where the rocket is launched, the deployment, the first parachute is released, gyroscope is activated, second descent control, and all these things were designed in our laboratory by our students. So you can see a design configuration. These all software, 3 softwares where we were not aware when we were not in the team. When we joined the team, we were designing all the 3D designing, AutoCAD, etc. So this is the design which you are seeing developed by our students in our center. So this is a design configuration of an CANSAT. This is an overall structure of a CANSAT. So these are our in AutoCAD 360, which you can 3D design and model it. This is a design configuration, complete design configuration and subsystems part by part. All the sensors, electrical power systems, etc. And the mechanical gyro control. So gyro is something which stabilizes the CANSAT while it is descending, and it has to have a smooth landing also. So here are other additional objectives such as camera payload. So these are all the designs which designs and the concepts are developed by our students. So what did we learn from this competition? So this competition taught us a lot of mission creation, how the requirement is defined, and how it has to be done in a sequence. So the generation of satellite, the architectural design, everything was done in our center, and the system analysis such as power budgeting, weight budgeting, etc. were done by us. And subsystem design and fabrication, development process, design review and project management, assembly and integration and test, etc. And we learned how to do a field test of a rocket or a balloon, etc. So the ground operations, uplink, downlink display, etc. There are a lot of knowledge which we gained through this competition. So I thank our center and our staffs for providing this opportunity to learn and explore this space. Dear friends, do you want to know more about CubeSats and CANSATs on the satellite mission? I have Ms. Tarni here to present on CubeSats. Thank you.
Good evening, everyone. Myself, Bala Vigneshwari. Sorry for this inconvenience. So, let me introduce myself. Myself, Bala Vigneshwari. I'm from Dr.M.G.R. Educational and Research Institute. I'm pursuing my BSc Physics third year. So, currently in the stream of satellites and rockets, there is a one bias is there, like engineering students can do it, not like that. We can also do it. So, I'm very proud to be a part of this mission. So, I'm basically working in rocketry field. So I have participated in Battle of Rockets. So Battle of Rocket, it's an international event that is used to design rockets in solid propellants. So let me have an introduction. Rocket, basically we are using rocket means we are going to deploy one orbit, deploy in orbit of a payload. So we are going to do that by using some propellants like solid, hybrid and cryogenics. So why we need rockets other than some vehicles? So rocket from other vehicles, why means the mass of the propellant is varying from vehicle to vehicle. The consumption of mass, like if we are using petrol means the car will consume it in constant consumption. But according to rockets, it's having a huge mass loss. So according to Newton's law, it may vary. So rocket science is different from other vehicles science. So mainly I'm working under a solid propellant rocket. We are having different parts. So parts of the rockets are mainly nose cone, body tube and fins. So why we are using nose cone means to avoid the drag force. If you are going to launch a rocket, it will have the force that is going to oppose the rocket from upward sides. So we are going to face it means we need a nose cone for a rocket. It is having around 5 to 6 shapes. So nose cone is the mainly important part of a rocket. Then body tube. The structure of the body tube plays an important role while launching the rocket. Then we are moving towards fins. Fins are used to stabilize the rocket. And motor part. Motor part is mainly we are using solid propellant. So it's a motor series around having from A to K. Uh, it's a it's like we are having a more fuel. It's going around O, then it's from A to O. Okay. Then parts of the rocket are secondary parts are centering ring, bulkhead. Centering ring is mainly used to hold the propellant, that is motor part, and bulkhead is going to hold the payload which we are going to launch by using our rocket. And engine mount, it's similar to centering ring, but it's going to hold the entire propellant area, that means motor. Then parachute is having very keen important in this field, because it's going to make our rocket to fall into earth again. Then our problem statement, mainly what does that means? We are going to design a single stage rocket. Rocket can be classified into different stages: single stage, double stage rocket. It means we are going to launch stage by stage. So from deployment, one stage is there, then other stage. From first stage, the first motor will be deployed from the rocket, like that. So designing a single stage rocket with apogee of 1,000 feet. Apogee means maximum height. So we are going to we designed a rocket that is going to go around 1,000 feet. Then it's going to deploy a payload, that is a jumping robot. So jumping robot means it's need to free fall from that height. Then after that, it need to land in a soya beans field. That's the toughest part in this problem statement. Then we are having a commercial altimeter. So altimeter is basically used to measure the height of the how much height the rocket is going on. So the robot that is free falling from that height needs to land very properly. Okay. So it's the very hectic problem statement, but we have done that. So what are the materials we used here for nose cone, body tube, fins are listed here. And me and my team designed this rocket from Open Rocket software. It's a single stage rocket which can go up to 1,000 feet. So it's having the basic structure of the rocket is this. You can see the parachute and centering rings here. Motor is there. So mainly in rocket science, we are developing a rocket here. So this is the 3D design and this is the 2D design of the rocket. And this is the stimulation graph of my rocket. That means our rocket. So you can see the apogee and acceleration burnout time from this graph. So fabrication of rocket, how we are doing this, we are using K motor series. I already intimated by using solid propellants we can classify the motors from A to O. So like that we are going to use K motor series. So deployment will be like this only. So after launching the second stage, ignition burnout is completed. From fourth stage, it's a free falling and the payload is deployed. Then in fifth stage, we can collect the rocket debris and we can reuse it. So next, the main theme is jumping robot. That means our payload for that competition. Jumping robot is mainly like we need to jump around some feet. After free falling, it needs to jump without any contact with it. So we need to use some technologies to develop. So we used that, and our jumping robot need to jump around 20 centimeter after the deployment, and we need to have a portable ground station on the time. So we developed it, and our jumping robot is made from the biomimicry of grasshopper. First of all, let me give what is meant by biomimicry. Biomimicry means copying from nature. Like you are copying something from nature, that is known as biomimicry. So we are doing it from grasshopper. So basically you guys are seeing that how grasshopper jumps from ground to another area. So it's jumping, and then the mechanism, it's using its tissue, leg tissue to jump. What it will do means it will store all the energy to its leg, then it will give a momentum to jump. So from that we copied the mechanism to design our jumping robot. So we are designing it, and it's a very craziest thing to do, but we are doing it. And thank you for this opportunity, guys, and thank you for everything. Thank you.
So, good evening, everyone. Thank you for letting me to introduce myself. My name is Tarni. So, from Dr.M.G.R. ACS Space Technology Center, Department of Information Technology. I'm doing my final year. So, the first step towards the space program was initiated by taking part in an ambitious mission of 75 student satellite mission, themed to build satellites by Indian students. I'm proud that our college is a part of this mission. Dr. M.G.R. ACS CubeSat mission is a huge ongoing project in our university. Being an IT student, initially, I don't have much understanding and exposure in satellite field. So through our Space Technology Center, I have acquired enormous knowledge and hands-on experience towards designing and fabrication of CubeSats, CanSats, battle of rockets, and much more. I've learned about nuances of satellite development software tools such as Fusion 360, Arduino IDE, OpenRocket, ECDA, so which is PCB designing software, and so on. Now we can dig a little bit deep about what is CubeSat. Have you heard about what is a CubeSat? Or so, as you all know, you have heard about cubes, right? So, which is a small size which can fit in your hand. So, think of it as a cube which just fits in your hand. And you have learned and heard about satellites. So, have you ever heard about CubeSats? So, where cube and the satellite which is being integrated. So that is amazing how it comes like. So as you can see, this is the structure of CubeSat. So do you know how much does it weighs, or what is the size of it? Imagine that the size is just one unit. That is 10 by 10 by 10 centimeter. It's too small and compact structure. It weighs around 1 kg. So less than 1 kg it weighs. So isn't it shocking to hear this? So that's how CubeSat is made. The advantage of which is its size and the compact structure. So as you can see here, there are 4 antennas inserted in it, so which helps for the reliable transmission and receiving of radio frequency signals from the satellite to the ground station. There arises a question, right? So where these satellites will be launched into the orbit? More specifically, these satellites will be launched in the lower Earth orbit. So can you please move on to the next slide? So these satellites will be launched into the lower Earth orbit. So here we are using LoRa IoT device for communication purpose. So once we have launched into the orbit, as I've said, the 75 student satellite, we are building 75 satellites. So those 75 satellites will be in Starlink constellation. So think of it, it is a small cube and all the components are being integrated. So next slide, please. So this is the internal structure. So this is how all the components is being inserted in the CubeSat. Next slide, sir. And this is the overview. As you can see there, the 4 poles. So which keeps the compact structure, which is strong, the small and compact structure, which keeps it perfect and reliable one. Next slide, please. As you can see here, so think of inside a small cube. So more than 5 and 6 components has been integrated into it. So these are the 5 major components, so subsystems, which act as a main thing to the satellite. That is EPS, OBC, communication structure, and ground station. These plays a major role. Once you have decided that, once you came into the CubeSats, these plays a major role. Next slide, sir. So as you all know that crossing the international border is a huge problem which has been encountered in many countries. So here we are addressing an exclusive solution for our International Maritime Bureau. Our satellite payload is intended to assist the fisherman's life by intimating while they cross the border. So this is the main aim. And then the further is creating a way to communicate from sea to seashore. So in that cases, a mobile communication is not much helpful. So there we'll be using the satellite communication and then sending caution to fishermen at sea about the weather condition and emergency alert. So if any natural disaster occur, so we'll be giving a portable device to the fisherman where he'll be giving intimation, and further that signals will be transmitted through satellite communication. So this is what the main objective of our mission. And here comes the basic of satellite communication. So the communication is just amazing. Next slide, sir. Next slide, please, sir. So as you can see, this is the uplink and downlink. This is how the transmission occurs between the ground station and the satellite. And then on the other side, there will be the fisherman. Next slide, sir. So here comes the visualization. Okay, then I'll be continuing it. So there comes a visualization. So in that will be exactly, it will be shown how the fisherman can communicate with the ground station people. So consider an example. So now the fisherman is in caution. So he needs some help. At that time, the device what he have, he will be giving intimation to the ground station people. So that will be communicated with the help of satellite communication. Further, there will be many ground station nearby the fishermen, so nearby seashore, they will be intimating their families, or they are in trouble or they are fine. These intimations will be done through the satellite communications. So the crown of students have been working together, and there comes an end. By doing so, our academic excellence increases through the process of knowledge creation, knowledge delivery, and knowledge application that are harmonious with our institution. So being a satellite student of MGR University, we are not limited only to satellites. We are ready to make landmarks in rocket field too. Do you want to know more about rocket technology? So which we had covered in the last class. So this is how our step goes on. And here we are still making to create a marvelous and encouraging center for others also to just show more knowledge and interest in satellite field. Thank you.
I'm Akshara Pushpan from second year chemical engineering. I'm also a part of Dr.M.G.R. ACS Space Technology Center. Space is very new for me when I was stopped myself into the team. Uh, I realized my role in satellite team as a chemical engineering student in cryogenic engine fuels and other chemical processes involved in it. We got opportunity to meet in and interact the eminent personalities like ISRO chairman S. Somnath sir and Dr. K. Sivan sir. He is the previously served as director of VSSC, and Vasagam sir, the director of Apple Satellite. And we had a great interactive session with the senior ISRO scientist, Mr. Gokul. And would you like to have such a learning environment like us? Then join our Dr.M.G.R. ACS satellite team. How to join? I'll tell you. So this is the way. This is the national seminar going to happen at 30 and 31st of Jan 2023. So this is the opportunity to get into our team. Opportunity not only once. This is the time. Block your dates, and we have limited seats only. So we have eminent speakers across the India. To know about this more about the seminar, visit our university website or department notice board or the WhatsApp group. Now we have our university virtual tour, which Mr. Jagadish will guide you to that. Thank you.
So now we are going to start our virtual tour by Jagadish. Jagadish, welcome. Jagadish, please unmute yourself.
Yeah. Myself, Jagdish from CSE AI department, here to state you the workings and functioning of Dr. M.G.R. ACS Space Development Center. Here we go. Like our university feel proud to be the part of certified student satellite mission. And in addition to that, I feel proud to develop a satellite development center in our university. Like we'll go and see the functioning of our lab individually. Before that, have an outer structure of a lab. Here we go, the National University Prestigious Center. Firstly, this is the lobby where our chief guests or any patrons will be staying here. And these are some CubeSat images electrical power board, subsystems, beacon antennas, so that we can have some information to the guest or visitor who visit our lab. Yeah. This is the clean room where electrical discharges are separated. So here we go. So the purpose of the clean room is to avoid damage of the electrical boards due to electrical discharge. Even our body have tiny electrical charges. So that charge will damage the electrical board. To prevent that, our clean room is well equipped with ESD flows, ESD toolkits, and ESD dress where the students who are performing the experiments or designing the chips will be fully equipped with the ESD kits. Just we'll have a look here. So here are our university students taking part in the cancer competition, building some chips. So this is the digital microscope, and where we can see the tiny particles of the board, and we can integrate, and we can specify. Yeah. Nextly we'll go to the fabrication room. This is the fabrication room where we design our own components like microcontroller, electric components like resistance capacitor. We build our own components. We are using 3D printers, and it's L equipped with antennas, spectrum analyzers, and other components. This is the 3D printing where we will print our own components. For the Battle of Rockets and Cancer competition, we ourselves printed the components using this 3D printer. Now, nextly, we'll go into the ground station, the conference room or meeting room of our team members. So, like, this is the ground station room where we use for telecommunication, live tracking, data receiving, analyzing, and the transfer. Currently, our satellite team members are working for a national conference, which is going to be held on January 30 and 31. Just we'll have a look over here. Yeah, it's all up to you now. We expect your young minds from our university to take part in our prestigious center. Over to you, Bala. Thank you.
So, thank you, Jagadish, for your wonderful speech and room tour. So, would you like to have a learning environment like our team? Then, dear students, you are always welcome. So, be a part of our national level seminar going to held on Jan 30 to 31st in our space technology lab. So, it's if you are having any queries and regarding this, it's our lab is functioning after college hours up to 8 p.m. in working days. So, be a part of our journey. Thank you.